Hi everyone, this is Chandan and you are watching the learning field. And in this session, we are going to discuss the numerical analysis questions paper of CSIR NET December 2025. So in this paper, there were total 3 questions from numerical analysis. In of these 3 questions, one question is of in part B, that is in 3 marks, and 2 questions are of in part C, that is of 4.75 marks. So total 12 marks, 12.5 marks was came in this paper of CSIR NET December 2025. So let's start to solve the question, and before starting, I'm requesting you to all those who are new in my channel, please give a like to this video, share it to friends, and don't forget to subscribe the channel. So this is the first question. This question is from part B, that is a 3 marks question. It says that if Px be interpolating polynomial for the data this one, then the value of P at half. So this is very basic questions of interpolation of polynomial. So first we uh, here write the difference table of interpolation. So see there y means this is the value fx we can write. So x and fx. So we first write x and fx. So this is equal to -2, -1, 0, 1, 2. Notice that these points are equispaced, fine, equispaced point, and fx equal to -1, 3, 1, -1 and 3. Now what is, we find the differences one by one. So first delta of fx. So delta fx means this minus this by this minus this. So 3 minus -1, 4. 4 by -1 minus -2 means 1. So that is simply gives us 4. Similarly, then we know that similar process 1 minus 3, that is -2 by -1, that is this is minus of 2. Then similarly 1 minus -1 means -2 by this is 1, so that is 2. Similarly we get this one is 4. Now then delta square fx, and up to how much of this delta square we calculate the table. See, one by one we discuss these things also. So this gives 4 minus 1 by, now this will be gap is 2. So that means 4 minus 2 minus 2 minus 4, that is -6 by 0 minus -2 means 2. So that is -6 by 2 means -3. Similarly, then this one is 2 minus -2 is 4. 4 minus 1 minus 1, 1, this 1 minus -1, that means 2. That means this value is -2. Sorry, this will be -2 minus -2. So that is -2 means this is 0. Similarly, 4 minus -2 means 6 by 2 minus 0, that is 2. This gives 3. Then the next delta square, delta cube fx. So now here the gap is 3. So 0 minus 3. 0 minus -3 means 3 by this 1 minus -2. That means this gives 1, and similarly this gives 1. Now the next difference is 1 minus 1 is 0. Therefore we calculate up to the difference up to the constant. If these two are constant, then we stop the calculation of calculate to the difference table, fine, because the next difference is 0. Now how can we write the polynomial by using this table? So we write the polynomial as in the form px is equal to, it starts from fx, that is -1, this is the constant term, then plus 4, this 4 into, then the value is first this one x minus -2. You can all write, I think, that x minus -2 means x plus 2, then -3 into, this is -3 into, this point include and this point include, these 2 point included. So that means x minus -2 means x plus 2 into x minus -1 means x plus 1 plus 1 into the 3 point, that is x plus 2, then x plus 1, and x minus 0 means only x. So this is the this is our interpolation formula of px. And now we have to find p at half. So put the value at x equal to half. P of half equal to -1 plus 4 into half means 5 by 2 minus 3 into 5 by 2 into 3 by 2 plus 1 into 5 by 2 into 3 by 2 into half. So this is equal to, this is minus 1 plus 10 minus 45 upon 4 plus 15 upon 8. Yeah. So this is equal to 9 minus 45 upon 4 plus 15 upon 8. So this is equal to 8 is the LCM, 72 minus 90 plus 15. So this is equal to minus 87 plus 90 by 8. So this is equal to minus 3 upon 8. So the answer is option A, minus 3 upon 8. Next question. Now this question is a part C question and it is of 4.75 marks. Now this question says that let A be a set of 2 by 2 matrix where A is the iterative sequence generated by the Gauss-Seidel method converges for every initial guess when employed to solve the system Ax equal to this B system, like this system is given like Ax equal to B. Which of the following statements are true? This belongs to S. That means these four, when which of these four options matrix are for which matrix the system converges. Find the matrix A. That is, you have to find this matrix A such that this system, that is Gauss-Seidel iteration scheme, is converges. Now before going to the solution, I will give some theorems and concept that is important, actually need to solve this question. So first of all, we have to know the, to solve this question we need the diagonally dominant matrix concept. Fine, because the convergence of the Gauss-Seidel iteration method or the Jacobi method is dependent on that. So here I first say here that what is the sufficient condition for convergence. If the matrix is strictly diagonally dominant, then the Gauss-Seidel iteration method or the Jacobi iteration method is also converges. If A is symmetric positive definite, then the Gauss-Seidel iteration method converges, or similarly for Jacobi method it also works. And what is the convergence criteria? The iteration converges for any initial guess if and only if the spectral radius of the iteration matrix is less than 1. Now I think you know the terms like diagonally dominant matrix, the what is spectral radius, what is iteration matrix, these terms. If you don't know what is this, so you can see my these lectures. These 4 or 5 lectures are very important for these types of questions, solving of these types of question. See here I already solve in my channel Jacob iteration matrix, Gauss-Seidel iteration matrix, how to find the matrix, what are the iteration scheme for these types of actually Gauss-Seidel method, Gauss-Jacobi method, what is diagonally dominant matrix, rate of convergence for Jacobian Gauss-Seidel, spectral radius, all the things I actually uploaded in my channel. Go to my numerical analysis lecture series, you will get these 4 or 5 videos. You can watch these videos, these 4 videos. I actually explain these topics very beautifully by the examples, with the help of examples. So you must watch these 4 video. Okay, now come back to this. Now to solve this question, just I will remind you, gives you one reminder that what are these terms. So first, here the system is like Ax equal to B system. Fine. Now what is the iteration scheme? The iteration scheme shows like x to the power k plus 1 equal to h x to the power k plus c, where this h is called the iteration matrix. Fine. Now for the Gauss-Seidel method or Gauss-Jacobi method, for the Gauss-Seidel and this is Gauss-Jacobi or only Jacobi method, what are the process to find this iteration matrix? Fine. So for the Jacobi method, this matrix H is like that, minus D inverse L plus U. What are the D, L, U? I just come. And this C equal to, we can write D inverse of B. And for Gauss-Seidel method, this matrix, iteration matrix is equal to minus D plus L inverse into U, and C equal to D plus L inverse into B. Fine. So these are the two iteration matrix for Gauss-Seidel method and Gauss-Jacobi method. Fine. Now, what is this D and L and U? So this A actually written as, these are the decomposition. A can be written as L plus B plus U. And L is a lower triangular matrix, D is the diagonal matrix, and U is the upper triangular matrix. You have to calculate these things to find the spectral radius. Now, what is the spectral radius? Fine. So spectral radius is generally denoted as rho of this iteration matrix A. This is equal to maximum of mod of lambda I. Suppose H is a matrix 3 by 3. H is a 3 by 3 matrix. Fine. So we will get 3 eigenvalues according to this matrix. So maximum of that modulus of the eigenvalue is called the what? The spectral radius. Now one more thing is the diagonally dominant matrix. Fine. So suppose there is a matrix, suppose A is a 3 by 3 matrix, A11, A12, A13, A21, A22, A23 is matrix. Okay. A23, A31, A32, A33. Fine. So if these three conditions hold for this matrix, suppose mod of A11 is greater equal to mod of A12 plus mod of A13, that is the for each row the diagonal element, modulus of the diagonal element is greater equal to the sum of the remaining others. Similarly for this is also, and for this also, that is for A last, I write the for last row, this is greater equal to mod of A31 plus mod of A32. If these conditions, and for the row 2 also, if these three conditions hold, then we say that the matrix is diagonally dominant matrix. The definition of this matrix is like that: mod of AII is greater equal to summation of j equal to 1 to n. In general, this can be written as I not equal to j modulus of Aij. Fine. So this is the definition of diagonally dominant matrix. Fine. This is the definition of diagonally dominant matrix. Now, what is strictly diagonally dominant? If this inequality holds in strict case, that is if mod Aij is strictly greater than summation j equal to 1 to n mod of Aij, j not equal to I. If this strict inequality holds, then it is called the strictly diagonally dominant. Now, these are sufficient conditions. That is, if the matrix is strictly diagonally dominant, then we say that Gauss-Seidel iteration method or Jacobi method converges. But if the matrix is not strictly diagonally dominant, then we can't say anything. Now, going to the question. So first we check what is that if the matrix are diagonally dominant, or the second sufficient condition is symmetric positive definite. So in the first case, option number 1, we say that modulus of 4 is greater than the other elements. Only there is 2 by 2 matrix, this is holds, and modulus of 3 is greater than modulus of 2. That means this is a strictly diagonally dominant matrix. Therefore this converges. That means this belongs to S. If we now check this one, the second option, so mod of 1, first one element is diagonal element, this one is not greater than mod of 2. Therefore this is not diagonally dominant. But if this is not diagonally dominant, we can't say anything, because of the diagonally dominant condition is the sufficient condition. Fine. Similarly here also mod 1 is not greater than mod 5. Therefore this is also not diagonally dominant matrix. And if we see this what the this condition that symmetric and positive definite. Fine. See, this matrix is also not a symmetric matrix. This matrix is also not a symmetric matrix. Therefore we cannot say about this sufficient condition. That means that sufficient condition of symmetric positive definite is not applied here. Right. Now for the fourth matrix, mod of -5 is greater than mod of 2s holds, and mod of -4 is greater than mod of 1. So these two holes for each row, that means this is a strictly diagonally dominant matrix. Therefore, this is also convergence. Now we have to check option 2 and 3 by using the our convergence criteria. That is, we have to calculate the iteration matrix. Now for the Gauss-Seidel method, this is the iteration matrix scheme. So we have to find D, L, and U first. So if we write here for option 2, suppose it is given that A is equal to what? 1, 2, 3, and 4. Therefore, D equal to simply diagonal matrix 1 and 4, 0, 0. Then lower triangular matrix equal to 0, 2, 3, 0. And upper triangular matrix is equal to 0, 2, 0, 0. Fine. Now, what is D plus L? We have to find D plus L inverse into U. So, D plus L, this is equal to what? D plus L is 1, and this is 0, sorry. 1, 3, 0, 4. This is D plus L. Now, D plus L inverse, this is equal to 1 by data, means 4 into what? This 4, 1 change their position and they with a minus sign. Fine. So 4103, this is D plus L inverse. Now what is the value of D plus L inverse? H is equal to into U. So this is equal to 1 by 4 into 4, 0, minus 3, and 1 into the value of U is 0, 2, 0, 0. This is equal to 1 by 4 into 0, 4 into 0, 0 into 0, 0. This is into 2, 8, this into 0, this into 0, 0, and this into 0, minus 6, I think. So we get this one. Fine. So this means what? 0, 0, 2, and minus 3 by 2. So this is clearly a matrix. The eigenvalues of this matrix are EB, or since this is a upper triangular matrix, so eigenvalues are what? 0 and minus 3 by 2. You can say directly. Now, what is the row of H? That is spectral radius of H. This is equal to maximum of the mod eigenvalues lambda i's. This is equal to maximum of 0 comma mod of minus 3 by 2, that is equal to 3 by 2, which is maximum, which is greater than 1. We need this spectral radius less than 1 for convergence, but this is greater than 1. Therefore, convergence fails here. Option 2 incorrect. Similarly, we have to check the option 3 also. Fine. So for option 3, the matrix is given as A equal to 1, 5, 1, 10. Fine. So here D equal to what? 1 and 10, 0, 0. And U equal to what? 0, 5, 0, 0. And what? L equal to? L equal to what? L equal to 0, 1, 0, 0. Now D plus L equal to, so B plus L, this is equal to what? 1, 0, 1, 10. Okay. And D plus L inverse, this is equal to 1 by 10. The determinant value is 10, 10, 1, 0, minus 1. This is the inverse. They change its position and they change with a sign. So this is the value. Now what is the value of D plus L inverse into U? This is equal to 1 by 10 into 10, 0, minus 1, 1 into the U is 0, 5, 0, 0, 0, 5, 0, 0. So this is equal to 1 by 10 into 0, 0, 0, 10 5 is 50, 0, 0, 0, and minus 5. Right? So this is equal to what? 0, 0, 5, and minus half. Fine. So this is also a upper triangular matrix. What are the eigenvalues? EBs of this matrix are 0 and minus half. Now what is the spectral radius of this matrix? This is equal to maximum of 0 comma mod minus half. Fine. So this is equal to half, which is less than 1. That means the spectral radius here minus less than 1. That means this is convergent. We need the spectral radius less than 1 for convergence mode of this. Okay. That means here the correct options are 1, 3, and 4. These are the correct options. Fine. You must watch these videos of that is available in my channel. Fine. I also prepare one ODE lecture series that is completely based on new syllabus of CSIR NET. Fine. One by one, I make all the lectures of ODE. Fine. So ODE, most change that happens in the CSIR NET syllabus is ODE and PD. I try to make the playlist ODE and PD, so you can definitely comment in the comment section below if you need. Okay. Next question. So this question is based on what? See, the question says that let xn be the convergent iterative sequence generated by Newton-Raphson method. What are the order of convergence of Newton-Raphson method? Order of convergence of NR method, we know that it is 2. For solving the equation sin x minus 1 equal to 0 such that xn tends to 2. That means this sequence xn converges to 2 as n tends to infinity. For n belongs to n, en equal to xn minus half. That means en is the error function, or error sequence you can say, that is xn minus pi by 2. Let p greater than 0 be such that limit n tends to infinity mod of en plus 1 by en to the power p exists and are non-zero. Then which of the following statements are true? First, what is the function that is given in the question? The function is fx equal to sin x minus 1. That means this is given fx equal to sin x minus 1. Therefore, we know what are the iteration scheme for Newton-Raphson method. Xn plus 1 equal to xn minus fxn by f dash xn. Fine. So this is equal to xn minus fxn means sin xn minus 1 by f dash xn means cos of xn. Fine. If we put xn equal to here, then this is the function xn. Okay. Now, therefore, xn plus 1 equal to xn minus this one. Now, what is given? Given that en equal to, there is a relation xn minus pi by 2. Therefore, from here we can put the value here. That means xn equal to en. This is error sequence. Fine. En plus pi by 2. Similarly, xn plus 1 equal to en plus 1 plus pi by 2. Now put these two value to the above equation. We get what we get? We get en plus 1 in this equation. Fine. En plus 1, this is equal to en sorry. If we put in this equation, so what we get? Xn equal to en plus 1 plus pi by 2. This is equal to xn value is en plus pi by 2 minus sine of xn. So sine of xn means en plus pi by 2 minus 1 by cos of en plus pi by 2. So pi by 2 got cancelled from both sides. So this implies en plus 1, this is equal to en minus. So sine of this means sine a cos b, cos is 0 minus cos a sine b. That means this is, I think, not I think, minus cos en minus 1, minus of cos en, not minus, only cos en, sin a cos b plus cos a sin b. Okay, and this cos means cos a cos b minus sin a sin b. So minus sin en. Now here we got cos and sin function, but here given in the question is, that is given in the question, which is completely in exponential, or sorry, en. So we can break in this Taylor series expansion. Fine. So how can we break this? Write the Taylor series expansion of sin n and cos n. So en minus, what is the Taylor series expansion of cos x? So cos x expansion is what is the expansion of cos n? So 1 minus x square by 2 factorial plus x cube by 3 factorial, or x to the power 4 by 4 factorial, not 3. X to the power 4 by 4 factorial, like this way. Now the Newton-Raphson method, the order of convergence is 2. So we write directly this is equal to 1 minus x square by 2. The other terms we don't need to write because the order of convergence of Newton-Raphson method is 2. Similarly, sin x expansion is x minus x cube by 3 factorial. So we replace this sin x by only x, that is the sequence in the sequence from xn, that is this is 1 minus en square by 2 minus 1 by this is only en. So this one got cancelled. This is equal to sorry, minus en, because this is minus. So en minus cancel, en by 2. This gives en by 2. So that means we get en plus 1 equal to en by 2. Only this one. Now, given that limit n tends to infinity, mod of en plus 1 means what is the value? Half into mod of en. This value we directly put in this equation, en by mod of en to the power p. Now you said in the question, given in the question, that this is exist and unique. Now if p equal to 1, directly we can say that if p equal to 1, then this limit is only half, which is non-zero and exists finitely. That means for p equal to 1, we got our answer, p equal to 1, and the value of this limit en is half. Now for p equal to 2, we don't know what is the value because the en value is not given. Limit n tends to infinity, half into 1 by mod en. This is remaining, but we don't know what is the value of en. Fine. Okay. So we don't take this option. Fine. So p is equal to 2 is not possible. So these are the here option A, sorry, 1 and 2 are the two options for this question. So these are the total questions of CSIR NET numerical analysis. So this is the complete solution of numerical analysis. So if this video is helpful for you, then don't forget to subscribe this channel. Fine. Because most of you are watching my videos but don't subscribe the channel. Please do subscribe the channel. And one more thing, I am going to make the OD lecture series first. I'll just making, now I am currently working on the making on the slides. So after some 1 or 2 classes slide will prepare, I will uploaded one by one lecture series. Okay. So definitely comment in the comment section below if you need this, and this will completely based on the new syllabus. The add-ons that have in the new syllabus, we will cover all the things one by one. Okay. Firstly, start from the basics, that is old syllabus, and some new topics that has added in the new syllabus. We will try to cover all the things. Okay. Thank you for watching. Bye.